Okay, so I'm going to go over ideal gas law. So the equation for this, or the formula rather, is PV equals nRT. I know when I first started chemistry, even though I had a pretty good math background, this equation used to always confuse me. So I'm going to break this up and make it as easy as possible. So first things first, we have T is temperature, and that is in kelvins. We have R. This would be your gas constant. And this number is 0.0821 liters times atmospheres over moles times kelvins. N is simply moles. And then let's do pink is volume, and that would be in liters. And then we have our last one is pressure. Pressure is in atmospheres, or ATM. So these are the units you're going to need to use to solve this. All right. Now, how would we use this? Actually, first let me go over some common pressure units. So units of pressure that are commonly used, and I'm going to put it in an equation. So we have 760 torr equals 1 atmosphere equals 760 millimeters of mercury. So these three are commonly used values for pressure that you're going to have to convert between depending on the problem. If you just remember that both sides of this equation equal 1 atmosphere, it'll make your life a lot easier. You might also have to convert from grams to moles. You might have to use information you found calculating the amount of moles and finding the molar mass of something. It all depends, and you can actually use this formula to calculate the molar mass of a substance and determine that substance based on the information given. It just depends. It's a very versatile equation. So I'm going to give you an example, and we're going to go through it. This one's kind of easy, but it still shows you how the equation is set up and used. All right. Calculate the volume occupied by 0.845 moles of nitrogen gas at a pressure of 1.37 atmospheres and temperature of 315 kelvins. So let's remember that it's PV equals nRT, and let's start setting it up. So we have 0.137. Oh no, I put 1.37, my bad. 1.37 atmospheres equals, or times V, equals 0.845 mole times the gas constant. I'm going to write this a little differently than you'll normally see it. It's usually understood that this fraction would be like this, but a lot of you guys don't really realize that multiplying by the fraction, the bottom goes on the bottom. So anyways, and then we're going to have 315 kelvins. So to isolate the V, we divide the 1.37 atmospheres out. So we divide the pressure out. So let's put a long line right here. Then you're going to have 1.37 atmospheres, and we'll be able to solve for V. So I'm going to rewrite this. V equals 0.845 moles times 0.0821 liters times atmospheres over moles times kelvins. And then this is multiplied by 315 kelvins. And then it's divided by 1.37 atmospheres. So let's start canceling units. So remember, if you have a unit over a unit, it cancels into the number 1, and it's gone. Moles over moles is gone. Atmosphere over atmosphere, it's gone. And then you cancel out the kelvins. So as you can see, the volume is left with all these numbers, but only the liters remains, which is what we want. So let's plug this into a calculator. So let me clear all this stuff out. Now to do this, open a parentheses and make your life easy. Don't try to solve this one step at a time. You're wasting time at that point. So 0.845 times 0.0821 times 315. Close the parentheses and you just divide by the bottom. Divided by 1.37. So your answer is going to be 15.95 liters. So do it in black. V equals 15.95 liters. Now, this was a very simple problem. Other ones you're going to be given Celsius. Do not be tempted to just try and solve it with the Celsius because it's not going to work. It needs to be in kelvins. You might be given grams. Obviously, grams is not equal to moles unless it's converted from the molar mass. But even then, it's not going to work. It needs to be in moles. So if you have the exact same grams as would be in 1 mole, you just need to write 1 mole. And that's really it for using this equation. It was really simple, but there is going to be some more challenging problems that you're going to be practicing in class.